Hello folks, welcome to week 4 of online classes. We're going to get started right where we left off, section 9.3. This time we're dealing with geometric sequences. Let's get started with that start thinking. Let's think back to what we were learning last week. What are the recursive and explicit formulas for an arithmetic sequence? Remember, the recursive one was the one where we needed the previous term. In the explicit formula, we could use any term. So the recursive formula said that our first term was equal to something, and then every term after that would be equal to our previous term, a sub n minus 1, plus d, our common difference. Remember, this only worked when we were dealing with numbers greater than 1, because we had to rely on whatever the previous term was. The explicit formula was our a sub n, our nth term, would be equal to whatever we started with plus n minus 1 times our common difference. And we could use this for any value. Remember, it's n minus 1 because our first term we're not adding that difference. So this was for arithmetic sequences. Today we're talking geometric sequences. How are they different outside of one just being used in geometry? Well, the name actually doesn't have anything to do with geometry. I don't really know why they're called geometric and arithmetic sequences. But a geometric sequence is a sequence with a common ratio. So a geometric sequence is a sequence with a common ratio. What does this mean? Well, it means if you take any term and you look at the term previous to it, right, take a sub 6 and divide it by a sub 5, that's going to be the same as a sub 5 divided by a sub 4 and a sub 4 divided by a sub 3, and so on. Essentially what it means is you are multiplying some number to get from one term to the next. We're thinking of it as a ratio here because we're dividing. Right? And if we're thinking about this, the arithmetic sequence, right, where we're adding, that acts linear. We're just adding some bit. But when we're multiplying, it starts to look exponential. So this one's going to grow at a much higher rate exponentially than arithmetic sequences. So what would be an example of this? It would be something like 1, 2, 4, 8, 16, and so on. What are we doing? To get from 1 to 2, we're multiplying by 2, 2 to 4, multiplying by 2. And what's happening? Well, 16 divided by 8, that's going to give us 2. 8 divided by 4 is going to give us 2. So we're going to have a common ratio. Our two forms of writing this, the recursive form, we're going to start again by saying our first term is just a, whatever the number is, and our nth term is going to be a sub n minus 1, the previous term, times our common ratio. Once again, this is for n greater than 1. The explicit formula, remember this was also much more handy when we were looking at large numbers, when we were looking at the 100th term, the 1000th term. The explicit formula is going to be a sub n is equal to whatever our starting term is, and we're multiplying it by r n minus 1 times. So this reads a sub n is equal to a times r to the n minus 1. All right, let's take a look at some of these. See if they are geometric or not. If we have 3, 6, 12, 24, 48, and so on, is this geometric? Well, what are we doing to get from 3 to 6? Multiplying by 2. 6 to 12, multiplying by 2. Multiplying by 2, multiplying by 2. So this is geometric, and our common ratio, what we're multiplying by, is 2. How do we write this recursively? Well, our first term is 3, and every term after that is going to be the previous term times 3. Oh, excuse me, not 3. Our common ratio is 2. The explicit formula is going to be a sub 1, our first term, 3 times our common ratio raised to the n minus 1. Okay, now what about this one? What if we had 3, 6, 9, 12, and so on? 3 to 6 we multiply by 2. 6 to 9 is not multiplying by 2. Right? Each time we're adding 3, so this is not geometric. Right, let's look at another one. Let's say you have 4, negative 12, 36, and negative 108. Right, let's look. How do we get from 4 to 12? We multiply by negative 3. 12 or negative 12 to 36, multiply by negative 3. So it looks like our common ratio is negative 3. Our recursive formula, our starting term is 4, and our a sub n will be a sub n minus 1, the previous term, times our new term. Remember, we have a negative 3 in there. And for our explicit formula, what's that going to be? It's going to be 4 times negative 3 to the n minus 1. Got to keep that minus 3 in parentheses, that way we're flipping the sign with each of these. All right, let's take a look at a couple more things we can do with this. Now with the arithmetics, we had looked at these and we said, what happens if we have 2 and then we have a couple of unknowns, but then we know our next term is negative 54? Well, when in doubt, we want to use what we do know, right? Back in geometry, we would start using the formula. So let's start there with the explicit formula. We know that a sub n will be equal to a times r to the n minus 1. What's a sub n? What's our biggest term? Well, we'll go with negative 54. Our starting term is going to be 2 times r. We don't know what r is, but how many terms do we have? 1, 2, 3, 4. So this is r to the 4 minus 1. We're going to divide by 2, so this gives us negative 27 is equal to r to the 3. How do we get rid of this 3 now? Well, we're going to have to take the cubed root. And what's the cubed root of negative 27? That's going to be r is negative 3. So we can use this. 2 times negative 3 will give us, our next term is negative 6. Negative 6 times negative 3 will give us positive 18. Positive 18 times negative 3 will give us negative 54. So we're all set there. All right, another example. Let's say we have some numbers in a sequence, 4, 16, 32. We know this is a geometric sequence. By the way, that's important for this previous one here. This is only if we're told this sequence is geometric. Can we do this? Okay, so we know this is geometric, and we're trying to solve for a sub 10. How would we do that? Well, let's start. Do we want to use the recursive formula here? We only have up to 3. We don't want to have to do this another 7 times. So let's write the explicit formula. What's the explicit formula? It's a sub n is equal to a times r to the n minus 1. What is a? It's 4. And how much are we going up by each time? We're multiplying by 3. So this is going to be 4 times 3 to the 10 minus 1, because we're looking for a sub 10. And then this is going to come out to be something really large, 4 times 3 to the 9th. So we're going to put that into our calculators, figure out what that's going to be equal to. And it turns out our 10th term is going to be 78,732. All right. Now, when we were dealing with the arithmetics, we had something where we said, well, what if we have something like 2 and then a blank, and then the next one turns out to be 6. We could find this using the arithmetic mean. I didn't call it the arithmetic mean last time, I just called it the mean because it's what we're used to. We can do the same thing with geometric sequences. This time it's called the geometric mean though. And the geometric mean is if you have a number and a blank and then something else, you're trying to find this, you know it's geometric, this middle term is just going to be equal to the square root of x times y. So all we're doing is we have to take the square root of x times y to find that middle term. So if we're looking at this and we see that we have 3 blank and then 36, we could do this the other way, figure out what our ratio is, try to do all of that, or we could say this middle term is just going to be the square root, not 36, this is going to be 12. So this middle term is going to be the square root of 3 times 12, or the square root of 36. So this term in here is going to be 6. So remember, when you have just one term missing, you can just multiply the two terms, take the square root. If you have multiple terms missing, where is that? You're going to have to figure it out using this method. But for just one term, you can just take the square root and find it that way. All right, that's all we have for this lesson. So let's get to some practice. I want you to tell me whether this sequence is geometric. I want you to find the recursive and explicit formulas for it. And then also tell me what a sub 10 is going to be. What's the 10th term going to be? When you're done with that, here's another one for you to do. We're given 3, we have 2 blanks, and we know that this term is 192. If this is geometric, what are those middle two terms going to be? And then finally, tell me what the middle term is going to be for this. So pause the video, go ahead and do all of these, and then we'll meet back up. All right, welcome back. Let's get started. Looking at this first one, what are we doing? So 8 divided by 2 is 4. 32 divided by 8 is 4. 128 divided by 32 is 4. So it looks like these are geometric, and our ratio is going to be 4. So what's the recursive formula going to be? Well, our starting term is 2. And our formula is going to be a sub n is equal to a sub n minus 1 times our ratio. So there's our recursive formula. What about our explicit formula? Our explicit formula is going to be a sub n is equal to our starting term times r, which is 4 to the n minus 1. Now for solving for a sub 10, the 10th term, do we want to use the recursive or the explicit formula? Probably the explicit, that way we don't have to do this an extra 5 or 6 times. So we're going to say a sub 10 is equal to 2 times 4 to the 10 minus 1. Or 10th term is equal to 2 times 4 to the 9th. Throw that into your calculators to figure out what that's going to be. Get 2 times 4 to the 9th. And it turns out your 10th term is going to be 524,288. So that's your answer for what your 10th term is. All right, for geometric sequences. We're looking at this. We know this is geometric. We're trying to find these two terms. What do? Well, we don't know where to start. When you don't know where to start, look at the formulas you do know. We know the explicit formula for geometric is a sub n is equal to what our original is times r to the n minus 1. And now we can put in what we do know. We know that our big term, 192, is going to be equal to 3 times whatever our ratio is to the, how many terms is this? 1, 2, 3, 4. So this is going to be 4 minus 1. Let's divide this by 3. So we get 192 divided by 3 gives us 64. So we know that 64 is equal to our ratio cubed. How do we get rid of that cube? Well, we're going to take the cubed root. And the cubed root of 64 is going to give us r is equal to 2. not 2, 4. This is what happens when you do math in your head and not in a calculator. So we get r is equal to 4 here. Now, all we're going to need to do is multiply each of these terms by 4 to get to the next one. 3 times 4 is going to give us 12. 12 times 4 is going to give us 48. All right, and for problem number 3, we're trying to find this middle term. That's a geometric mean. So all we have to do is we have to take the square root of 5 times 180. Or that's the square root of 900. What's the square root of 900 going to be? Well, that's going to be 30. So our answer for that is 30. Right, that's it for this lesson. Remember, geometric sequences are multiplied. So we're multiplying everything here. Remember our two formulas, our recursive and our explicit formula, and get going on that homework.